Hello and welcome back. So in this question it says that a cycle bridge has been constructed using a Warren girder truss loaded as shown. Diagram is drawn to scale. So that's the first key bit of information, is that this diagram is drawn to scale, which means you need to get out your rulers and your protractors and go to town. Now, by considering necessary loads and reactions, calculate the magnitude and nature of the force in member C. So the second bit of information here is the word necessary loads and reactions, which they're kind of giving you a hint that you don't need to calculate both of the reaction forces. Okay, so they want us to find the force in member C. So to do this, we're going to employ the method of sections. Now, when doing method of sections, we create a cut that goes through the member C. So now when I do a cut through C, I then have to determine whether I take the left-hand side or the right-hand side. Now in this question, whichever side you take, it's the same difficulty, but I will be taking the left-hand side. Now since I'm going to be taking the left-hand side, that means I need to find the reaction force at roller joint A. So to find the force at roller joint A, I need to do sum of moments about B, so I can find the force at A. Alright, so that's the first thing we're going to be doing. So don't forget that a roller joint only has one force, which is 90 degrees to the joint. So I'm going to do sum of moments about joint B equals to 0. So I've got one. So remember, moment is force times perpendicular distance. So I'm going to have 1.2 times the distance to B. Now, if you were to take out your ruler and measure it, each of these lines are 35, or bottom lines are 35 millimeters. 35, 35. So the distance from 1.2 to B is 140 millimeters. Now you can use millimeters or centimeters, you'll still get the same answer. Then I've got the force at A. Now, before I go through that, the reason why I've got 1.2 times 140 as positive is because it's traveling in a anti-clockwise direction, and I've assumed anti-clockwise as positive. Then I've got the force at A, which will go in a clockwise direction, so it's going to be minus A times 35 plus 35 plus 35 is 105, plus I've got the 20 now, which is going in anti-clockwise direction, times the distance to B, which is 70. And then I've got the 3 kilonewton at top, which is also going in an anti-clockwise direction, times the distance. So I need to measure this perpendicular distance here, which happens to be 30 millimeters. So 3 times 30. And that's equal to 0. So now do the maths and you get 105A. So I've just chucked that to the other side of the equation, equals to, put that in the calculator, you get 1658. Divide both sides by 105 and you get A is equal to 15.79 kilonewtons. And we've assumed it going up and we still get a positive answer. So that means we've assumed correctly. So that's the first step in solving this question. Okay, so the next step now is to find the force in member C. So like I said at the start, I'm going to make a cut through the member in question, and then I'm going to consider in this case the left hand side. So now what I do is I will draw a free body diagram. So let's just label so we don't get confused. So I'm going to draw a free body diagram. So we've got this, that. Now the force that the members that have been cut become forces. So this becomes a force. This is my C, that becomes a force, and this thing here also becomes a force. I've got 1.2 kilonewtons going down here. I've got the force at A, which we found to be 15.79, and I've got the 20 coming down here. Now, if you were to get a protractor and measure the angle, this angle here is 60 degrees. We've got 35 here and 35 here. Okay, now that the free body diagram has been drawn, I need to determine which equation I need to use. So we've got the three main equations, which is sum of forces in the vertical, sum of forces in the horizontal, and sum of moments. So let's take this equation first, and let's see if we can use this equation or not. Now, if I was to use sum of forces in the horizontal direction, I have to see how many unknowns I have. I've got one unknown here, and I've got another unknown here, and I also don't know what C is. So I've got way too many unknowns, hence I can't use that equation to solve the problem. However, if I was to use the sum of forces in the vertical direction, this has no vertical, this has no vertical, this does have a vertical, so that means I only have one unknown force in the vertical direction. So that's the equation I'll be using. So sum of forces in the vertical direction equals 0. I have 1.2 going down, so it's negative 1.2, 15.79 going up, negative 20 going down, and now the C I need to break up into its components. So if I take C, remember when we are drawing our vectors, we start from the tail, so we're going to go right, and we work towards the head, so we go up. This is the right angle here, this is 60 degrees, so this one here is going to be opposite, so it's going to be C sine 60, and it's going up, so it's positive. So plus C sine 60 equals 0, and then from here we just simply solve it. So we have C sine 60 and put all the other stuff to the other side equals, what do I have here, 5.41, and then divide both sides by sine 60 and you get C is equal to 6.25 kilonewtons. Now because it's positive, that means I've assumed the direction to be correct, so it is indeed going this way. Now we need to determine the nature of this force. Now since the force is going away from the joint, we say that it is in tension. So if the force is going towards the joint, we say compression. If it's going away from the joint, then we say it's in tension. And there's your 6 marks.